Hello everyone. Today we are going to understand how to balance the redox reaction by using ion electron method. It is also called as half reaction method. Half reaction method means first we have to identify oxidizing and reducing species, then we have to separate oxidation and reduction reaction, and then we will balance each reaction separately, and at the end we will join both the reaction to form the redox reaction. Okay, so the example is given here. It is Mn2 plus. Okay, it is a 2 plus is oxidation state of magnesium, and ClO3 ion having negative charge. Okay, they gives MnO2, which is manganese oxide, and ClO2. Okay, so these are the two product of this reaction. Okay, now we had to check whether which species is going to oxidize and which species is going to reduce. First we have to identify that. Okay, so we had to obey the first step here. Okay, first step, it says write the unbalanced equation for the redox reaction. Okay, so first we have to write the given reaction as it is. So we have Mn2 plus ClO3 negative plus equals to MnO2, okay, plus MnO2 plus ClO2. Okay, everyone? Yes.
Yes, sir.
Okay, sir.
So just check here which species is oxidizing and reducing here.
C103 is reduction, sir, and for Mn plus 2
Yes.
charge is oxidation, sir.
Yes. So if we can see here, we have to first assign oxidation number to all the atoms.
Sir,
in
that's
the reaction.
that is that chlorine, sir, after Mn?
Wait, I'm explaining everything. Wait a second.
Yeah.
Okay. We had to assign the charges first, and then divide the equation into two half equation, which is oxidation and reduction. So see, as we can see, Mn is having plus 2 charge here. So we have right here, we have written here the plus 2. See, we know that oxygen is having on ClO3, I'm writing here ClO3 negative. We know that the charge on one oxygen is minus 2. Here we have 3 oxygen, so we have to multiply it by 3. Now total
Minus
charge,
6.
yes, minus 6. See, in order to represent this is the negative ion, we have to separate one negative charge over here. Okay, if one negative charge will get separate, then how many will remain here? Minus 5, right? Is it?
Yeah.
Yeah. So that chlorine must have plus 5 charge in order to neutralize that. Now minus 5 and plus 5 will be get neutralized, and that one electron we have shown in the form of ion here. So the charge on chlorine is plus 5, as you can see. Is it? Yeah. Next side. Again on oxygen, on MnO2 we have minus 2 charge on oxygen. We had 2 oxygen, so I'm multiplying by 2. Now total charge on 2 oxygen will be minus 4. Do we have any charge here? No, there is no charge here. Okay, that means we had to neutralize that minus 4. So in order to neutralize minus 4, manganese must have plus 4 charge. So see here we have plus 4 charge. Is it? Keep replying.
Yeah.
Yeah. And here again that ClO2. Okay, see again on oxygen we have minus 2. So I'm writing here ClO2. It is ClO2. Again on oxygen we have minus 2. We had 2 oxygen, so we have to multiply it by 2. So we have now 4 minus, and we do not have any charge here. That means we have to neutralize that whole negative 4 charge. So for that we have to have positive 4 charge on chlorine. So see here we have positive 4 charge. Understood now how to assign the charge? Everyone, keep replying. Devanshika, Niyati, Srikar.
Yes, sir.
Okay. Now we have to identify which species is being oxidized and which species is getting reduced. So see here, Mn is having plus 2 charge. Okay, Mn have +2 charge here on reactant side, but on product side, Mn is having +4 charge. So Mn +2 converts into Mn +4. That means its oxidation number is increases. That means Mn again loses 2 electron. Okay, it loses 2 electron and forms Mn4 plus ion. Is it? Is it or not?
Yes, sir.
Yes. So here loss of 2 electron takes place. That means Mn is getting oxidized. So this is oxidation reaction. But in case of chlorine, on reactant side, chlorine have +5 charge and on reactant side having +4 charge. That means oxidation state or oxidation number is decreases here. And if oxidation number is decreases, that means it is reduction reaction. So here chlorine, I'm writing here chlorine over here. Chlorine having positive charge 5, it gains 1 electron, okay, and converts into Cl positive 4 charge. Is it? So here electron gain takes place, 1 electron. So if 1 electron is gained here, that means it is reduction reaction. So this is oxidation and this is the reduction reaction. Understood, everyone?
Yeah.
Okay. So we had to separate oxidation and reduction reaction. As you can see here, Mn2 plus equals to MnO2. It is the oxidation reaction. And ClO3 negative equals to ClO2. It is the reduction reaction. We have separated both. So here we have completed the first step. Okay. Now we had to go through the second step now. So second step, in second step, we had to balance half equation for the oxygen atom by adding H2O molecule on the side which is oxygen deficient. Okay, oxygen deficient means having less oxygen number. And so add, see, as you can see here, here we have 2 oxygen, but on product side, do we have any oxygen here in this reaction? No. Do we have? So first we have to balance the oxygen. So in order to balance oxygen on product side, I am adding 2 H2O. Okay, everyone?
Yes, sir.
Yeah. So see, here we have the oxidation reaction. It is Mn2 plus and we have added 2 oxygen water molecules here in order to balance 2 oxygen. Okay. Then, so add 2H2 in left side of the oxidation. And now we have to check for reduction reaction. See, in a reactant side, we have 3 oxygen here, 3 oxygen. But on product side, we have only 1 oxygen. So on, no, 2 oxygen we have. So on product side, we had to add 1 H2O, right? Is it,
Yeah.
everyone? Yeah. So on reduction reaction, we have added 1 water molecule in order to balance the oxygen. Now, step number 3. On step number 3, we had to balance hydrogen atom by adding H positive ion. Okay. Again, which side having less hydrogen atom. So as we can see here, on product side in oxidation reaction, we have 4 hydrogen atom. 4 hydrogen atom, right? Is it?
Yeah.
But on in reactant side, but on product side, we do not have any. So on product side, we had to add 4 H positive ion in order to balance hydrogen. Okay, so as you can see here, we have added 4 H positive ion on product side in order to balance hydrogen. So now reaction will become Mn2 plus twice H2O equals to MnO2 plus 4 times of H positive ion. Again, on reduction reaction, we had to check. So on product side, we do not have any hydrogen atom, and product side, we have 2 hydrogen atom. So on reactant side, we have to add 2 H positive ion. Now hydrogen will get balanced, is it? So as you can see here, on reactant side, we have added 2 H positive ion twice. Okay, otherwise all the reaction will be same. Understood?
Yeah.
Yeah. Now step number 4. Now we have to balance the charge. Now we have to balance the charge. See, now add 2 electron to the right side of the oxidation and 1 electron to the left side of the reduction reaction to balance the charge. Okay, so first we have to check the charge on oxidation and reduction. So see, on oxidation reaction we have +2 charge, and on reactant side, no, reactant side we have 2 plus charge only. But on product side we have +1 into 4 hydrogen, so total we have +4 charge. Is it?
Yeah.
Yeah. So on product side we have to add 2 electron. So 2 electron will be 2 minus. Now 2 minus and 4 plus will be +4 +2 charge. Is it?
Yes, sir.
Yeah. So by adding 2 electron, we have balanced the charge here. On product side, we have 2 plus, and on reactant side, we have 2 plus. So see here, on product side, we have added 2 electron. Okay, so now reaction will become Mn2 plus twice H2O equals to MnO2 plus 4H positive and 2 electron. Now we have to check for reduction reaction. See, in reduction reaction here, we have minus charge, 1 minus. Here we have 2 plus. Okay, so 1 minus and +2 charge. So what is charge remaining here? +1. Is it? +1 on reactant side. And on product side, we do not have any charge. Do we have any charge?
No.
No. So in order to neutralize that positive charge, we had to add 1 electron in reactant side. So one negative and one positive will get neutralized. So on reduction reaction, on reactant side, we have to add 1 electron. So as you can see here, we have added 1 electron on reactant side in order to balance the reduction reaction. Otherwise, all the reaction will be the same. Understood now?
Yeah.
Yeah. So by this reaction, as we can see, 2 electrons are lost, but only one electron is being gained here. So oxidation and reduction is balanced? No. It is oxidation is by 2 electron, but reduction is by 1 electron. So now we had to multiply reduction reaction by 2. Then if we multiply the reaction by 2, then we will get 2 electron will get again means reduction. Now oxidation and reduction will get balance. Is it?
Yes, sir.
If 2 electron is being lost during the reaction, those 2 electron have to be gained here. So that's why we had to multiply reduction reaction by 2. Okay, if we have multiplied reduction reaction by 2, so what will be the reaction? Twice of ClO3 over here. Then 2H positive will become 2 2s are 4H positive. Then that 1 electron will become 2 electron. That ClO2 will become twice ClO2, and H2O will become twice H2O. Understood?
Yes, sir.
Yes. So in this way, we had to multiply the reduction reaction by 2. So now here we had 2 new reaction. Which are these 2 new reaction? Mn plus Mn2 plus twice H2O equals to MnO2 plus 4H positive plus 2 electron. And the reduction reaction will be twice ClO3 plus 4H positive plus 2 electron equals to twice ClO2 plus twice H2O. Now here we have completed the balancing part. Now we have to add, see, this is the oxidation reaction and this is the reduction reaction. Okay, this is the reduction reaction, that one. Now we have to add both the reaction in order to balance, in order to have redox reaction, because we know redox reaction equals to oxidation reaction plus reduction reaction. Is it? So now we have to add both the reaction. So reactant side will be added, or both reaction will be on reactant side and product side will be on product side. So see, the reaction will become what? Mn2 plus, okay, Mn2 plus twice H2O plus, okay, it is not given here, so it is more, I'm just writing here, okay. See, I'm just adding both the reaction. So Mn plus 2 plus twice H2O plus, see, we have written this part for oxidation reaction. Now for reduction reaction, we have this reactant. So I'm writing here plus twice ClO3, sorry, twice ClO3 plus 4H positive plus 2 electron. So this is from the reactant side. Now for the product side, I'm writing with another ink. See, product, we have this are the product, and here these are the product. So I'm writing this here. So first we have MnO2 plus 4H positive plus 2 electron plus MnO2. No, here we have, these are not that one. Okay, twice ClO2 plus twice H2O. Okay, so see here that two electron will get cancelled because they are present on both the sides, so will get cancelled. 4 hydrogen positive and 4H positive will get cancelled. Then twice H2 on reactant side, twice H2 on product side will also get cancelled. So what is remaining here? So we have Mn plus 2 plus twice ClO3 equals to MnO2 plus twice ClO2. So now this is the balanced redox reaction. It is here we are negative, huh? So negative is here. Now if you will check by all the aspect, this reaction is balanced. This reaction is balanced now. Understood everyone?
Yeah.
Yeah. So this is the way you have to balance the redox reaction by half reaction method or ion electron method. Now, if you want to take a screenshot, you can take screenshot one by one. Wait a second, I'm just providing you the portion for that.